Assalamualaikum and greetings to the audience. So today my group 3 for computer programming BDA24202 will present about our group project. So before we start our presentation, I would like to introduce my team. So the first one we have the leader Kelvin Diojoni, and the second one is Krisma Anak Biga. The third one is Siti Aisyah binti Johari, and the last one is me myself, Muhammad Alif Hakimi. Okay, first and foremost, to kickstart the presentation, I will present the introduction part for this presentation. Okay, so for our project, we decided to develop a program for a lathe machine. So this development involved 3-in-1 program to guide the lathe machine in conventional machining operation, which is first one is drilling, second one is turning, and the third one is facing. So for the objective for our project, we want to complete the requirement of BDA24202 Computer Programming subject in the group project assignment. The second one is to be able to implement the knowledge learned throughout the semester in the group project. Third one is we are managed to use C language and implement it in a real life work situation. And the last one is to be able to manage to develop a program related to the title chosen. Okay.
So for the safety precaution, firstly we have to remove the chuck key from the chuck immediately after use. Next, it is important that the chuck or face plate is securely tightened onto the spindle. Next, we have to make sure the tool bit is sharp and has a correct clearance angle. And lastly, do not run a threaded spindle in reverse.
For the operational analysis, first is the cutting tool setup. Set up the cutting tool point to center height. We need to check it with straight ruler or tailstock. Secondly, mounting the workpiece. Place the end of the workpiece in the chuck and slide the tailstock up until it supports the end of the workpiece. The third step is installing the cutting tool. The cutting tool is installed in the tool holder. The installation, the holder must be clean and tightened to the bolts. Next step is positioning the tool. Loosen the bolts that keep the workpiece attached to the saddle and adjust the workpiece to the correct angle. Lastly, tailstock center. Tailstock is the reference to its center when setting the tool.
Okay, for the first operation, which is turning. So for the turning procedure, I will focus on rough turning. So the first step is set the lathe machine to the correct speed and also feed rate. Second one is adjust the quick change gearbox for a specific dimension of feed depending on the depth of cut and the condition of the machine. The third one is move the tool harder to the left hand side of the compound rest and set the tool bit to right hand to center. The fourth one is tighten the tool hose securely to prevent the tool holder from moving during the machining operation. The next one is take a light trial cut at the right hand end of the workpiece. Next step is measure the workpiece and adjust the tool bit for the proper depth of cut. Next step, cut along the designated length and stop after certain period to check the diameter for the size. And the last one is measure back and readjust the depth of cut if necessary to obtain the desired dimension as designed in the project.
For facing procedure, firstly we have to move the tool post to the left hand side of the compound rest and set the right hand facing tool a little bit to the right head of the lathe machine center point. After that, we have to mount the workpiece in the chuck to face by using a line center in the tailstock or straight ruler if needed. Next, we have to insert a facing tool. After that, we have to position the tool slightly off from the part. After that, we have to set the facing tool bit pointing left at a 15 to 20 degree angle. The point of the tool bit must closest to the workpiece and space must be left along the side. Next, we have to set the lathe to the correct speed and fit for the diameter and type of material being cut. After that, before turning the machine on, turn the spindle by hand to make sure part do not interface with spindle rotation. Next, we have to start the lathe and bring the tool bit close to the lathe center as possible. By move carriage to the left using the hand wheel until small cut is start. Next, feed the cutting tool bit inwards to the center by turning the cross feed handle. After that, repeat the procedure 6, 7 and 8 until the workpiece is cut to the correct line. Finally, there will be a sharp edge on the workpiece after facing and should be broken with a file.
The next process is drilling. The procedure of drilling is, firstly, we need to mount the drill chuck into the tailstock while the workpiece into the chuck. Secondly, we need to ensure the drill face is centered in line and properly secure in the tailstock. Place the tailstock to the desired position and turn the spindle by hand to make sure the part does not interfere with spindle rotation before turning on the machine. Next, step number 4, we start the hole by using a center drill tool bit and allow the usage of cutting fluid along the process. Mount the drill in the drill chuck and set the lathe to the proper speed of the type of material to be drilled. Next, start the lathe machine and drill to the desired depth. Make sure applying the cutting fluid along the process takes place. The usage of pit drill operation to remove the chip and measure the depth of the hole. Next, to remove the drill chuck from the tailstock, throw it back around a quarter turn. We need to use a pin to press the chuck out of the collet.
Next, we are moving to the criteria and the calculation part. For the criteria of our project is we need to find the cutting speed, the feed rate, the depth of cut, and the machine time. The formula for cutting speed is pi times diameter 1 times the rotational speed and divide by 1000. For the feed rate is the formula is the feet per revolution is times spindle speed, and the formula for depth of cut is the diameter before process minus diameter after process, and we divide by 2. The last one is the time machining length divide by feet per revolution times spindle speed. So the D1 is, as you can see on the right part of our slide, is symbol properties. The D1 is diameter before process, D2 diameter after process, D is diameter of workpiece, and the spindle speed, L is the length of job, F area feet per resolution, and pi is the value of pi is 3.142. So this is the source code of our project. So the first one is include the studio hatch and the mat hatch. So on our project, on our coding, we are using void. There are 3 types of function we use. There is void, main, and what else? We are using also array and function, also loop to make our project. So the first one we using the void menu, void turning, facing, reeling, and float pi equal to 3.142. So as you can see on the left side, we have system color. I've changed to change the result of the coding. Then I print f all the uh, word. Then moving to the void is we using array to differentiate three of the process, that is turning, facing, and drilling. Then when we process, while the process is not equal to 3, we are scan f the process. Then while the process is uh, 0 and 3, we are process the process. Then when the value is 3, we will print out the thank you for using the Lathe machine and have a nice day, stay safe. Later I will show you on the result part. Then after that, we are using void menu to differentiate all the part. So the first one is the void menu. As you can see on the right, coding on the below void menu. For the 0 is turning process, 1 is facing process, and if we enter 2, it will be drilling process, and if we choose 3, it will end the process and enter selection. Then the void turning, we are using the float to differentiate all the properties. Printf, when on the void turning process, if the diameter after the process is greater than diameter before the process, the process, it will not work, and it will run the diameter value is wrong, as you can see on the right side, coding value. Next, we are using the void facing to the facing part. We are using also float to differentiate all the properties. We entered the formula. Then the drilling part, we also use float, same as facing and turning point. So here I will show you the result for our coding. This is the first one, the turning process error. When we choose turning process that is 0, when we enter the value diameter is 12 and the diameter after the process also 12 or more than 12, it will the result will the diameter value is wrong. So that means the process is wrong. So when we, as you can see on the right side, the second one is the value of the process is running and the analysis of turning process is calculated. Here the result for the fetching process. We choose 1 for fetching process, then we enter the value of all the properties and it will show the analysis. Same as drilling, we choose 2 for drilling and we enter the value of properties. It will show the analysis of the process. And the last one, if we want to end the process, we just need to press 3 and it will appear, thank you for using Lathe machine and have a nice day and stay safe. Next part, limitation.
For limitation, firstly we have limitation in communication. This is because we have no face-to-face class, so it will have some interaction during our discussion. Next, we cannot have a physical inspection of machine that relate to our project due to MCO, which is Lathe machine. Lastly, some of our teammates are limited in their computer specification and resulting in a slow compilation when doing C language coding.
Next, to conclude our presentation, although we face many problems and limitations in completing this project, we managed to encounter it without giving up easily. We also managed to achieve our objective and able to complete our project successfully. We managed to apply our knowledge that we learned throughout the semester in this group project. It is a good opportunity for us to challenge our knowledge and capability regarding this subject. We hope that we can use this knowledge in the real working environment in the future. That's all for our group. Thank you.